Today we're going to be going through service information and how to navigate it. I am recording this on QuickTime Player. If you guys are looking for a resource for recordings for future reference and you're on a Windows or a Mac machine, QuickTime is a free integrated tool that comes with service information. So going into the one of two subscriptions we have access to as a program, we've got ALLDATA on one side and we've got Mitchell or ProDemand on the other side. Both of these are subscriptions you guys have access to on campus, anywhere that's IP based. To go to ALLDATA, you're going to type my.alldata.com/IP. It'll rearrange the website information. It'll take you directly to this link. Now, when you're in the site, you'll see on the college's network, you'll see you've got two main options on this page. One is repair, one is community. We're going to look at repair today. The reason being, we have to define really what service information is. As technicians, we rely on service information for specifications, standards, procedures, labor times, and feedback to provide manufacturers and other technicians within our network of repair technicians on the light-duty truck passenger car side and Class 1 through Class 8 medium and heavy-duty truck bus transit options. So I'm going to go ahead and click Repair. You'll see here I've got a screen that's generated. Over on the right-hand side, you can see recent vehicles that have been searched. So chances are you're in class this semester, you might have been the one that searched in service information for info on these particular vehicles. So I'm going to select from the left-hand side. Let's see. I'm going to pick a. I'm going to go with a 2001. Now this is a pretty old vehicle, one that I used to own, Ford Focus wagon. Now notice when I generate the vehicle, I go from year to make to model. I also get some descriptors of potential submodel options. So this list shows me that I've got a longitudinal 4-cylinder, 2-liter, dual overhead cam VIN 3. And we're going to look at VIN information as we progress through the course as well to understand the critical information a VIN provides us. Also, if we go to the GM world, we'll look at what RPOs mean and how they help identify specific models and submodels of vehicles when we're looking for parts or pieces in a repair process. So, click on the vehicle. I verified the year, make, model, and the engine code listed here. You'll see on the left-hand side, ALLDATA has integrated what's called popular information. These are usually quick points of access for us as technicians. I've also got a center column that says systems and components, so we get a broad array of systems and components for this particular vehicle, and then we get also specific information that comes from the manufacturer. How to identify components on a vehicle, where components are located at, where connectors, grounds, harnesses, splices are located on the vehicle, generic service precautions for servicing this vehicle, manufacturer prescribed testing procedures for individual components and general or broad diagnostics, initial inspection and diagnostic overview, symptom-related diagnostic procedures. And down here, this is, I don't want to say it's extremely new, but it's fairly new for the ALLDATA option. On our end, we see community repairs. So each one of these community repairs gives us kind of interactive responses on things that might be common or things that might be prioritized on this particular vehicle that the aftermarket has encountered as part of their service procedure. So since most of you are in my electrical class, my electricity, electronics, and intro to HVAC, I'm going to go ahead and go through service information and start right here over in the popular information side that says diagrams. Diagrams are going to be critical for us in the electrical side, as they will be for any other subsystem on the vehicle, because they give us a very broad but inclusive view of what parts and what pieces, where the components are located at on a vehicle that help us isolate maybe our diagnostic routine. Do I want to start in the front of the vehicle or the rear of the vehicle to deal with a no start? Do I want to start removing the front bolt on a lower subframe or the rear bolt? Those things will be included in some of the diagrams, at least on the mechanical side. But we're going to go into electrical. Now down here you see we've got two perspectives. One is OE, that stands for original equipment, meaning original equipment manufacturer. These are factory diagrams. And here it says electrical interactive color non-OE. This is a pretty common response we've seen in the aftermarket. The OEs don't always use a same standard or similar standard way to present their wiring diagrams. And I'll show you some contrast here. And we'll start with the electrical OE side first. So click electrical OE. And for example, I'm going to pick, let's see, blower motor. Manual air conditioning means I manually have to turn on the blower motor to force it to operate. So here is a factory diagram from Ford, and we might get numerous, which it looks like we are, that shows our power supply being a 30 amp fuse circuit in the battery junction box. Now notice there's a box around this where it says battery junction box on this Ford platform. If I click on this link, it'll show me what connects in the battery junction box on that particular vehicle, which is a nice integration of quick links within the factory diagrams that the folks at ALLDATA have integrated into the aftermarket side. So this diagram shows our power supply as a direct feed to our heater or blower motor. From there, we have 2 ground points. We have one for, note down here in this service information, all these terminal positions, 0, 1, 2, 3, and that should say 4, but on this diagram it says 11. 0 is fan is off. We don't have a ground point. Position 1 is low speed. So if we follow this down for the low speed feature, our power supply is going to come in, hit the blower motor circuit, and this portion of the circuit is going to act as the ground supply. Now here you notice kind of an awkward symbol. That symbol, the manufacturer will tell us what that is if we search in symbols and components within service information. What that is representing is a non-healing circuit breaker or a fusible link. So if we have too much amperage, too much heat going through this circuit, rather than burning the car down, this fusible link will open up and we will have no low speed, medium low, medium high. We will just have high speed. And that's something that this diagram can also help us with. And I'll walk us through this process specifically in service information. So back to low speed. This is my control switch. Now notice service information calls this out as the heater blower switch. We've got a solid line all the way around this component. What that means is it is not serviceable. You'll notice the same thing as is found in the blower motor resistor and also the heater blower motor. The components that have a solid box are all inclusive as a component, and the manufacturers do not recommend we tear these down. So that's going to be something critical within service information, at least on the electrical side. So we go to low speed. I turn my dial from off to 1. I want the fan speed to be low. If I connect this as a ground point, remember we have to have potential energy. Power is here. I connect this G14 to ground. Here we go. This is going to be my path. Power is going to come into the heated blower motor. Now I need to find a ground path. I'm going to go through this blower motor resistor and hit 1, 2, 3 resistors after the blower motor in series and go down to ground at this point at G14. So you can see right now, rather than having the only load in the circuit being the heater blower motor, based on this factory diagram, I have 3 other loads in the circuit in series. What that's going to do is reduce the total amperage in the circuit. As a result, we're going to get a low fan speed. We'll go to position 2 here, which says medium speed on the vehicle. I connect this to position 2. Now when I go to position 2, 1 was here, 2 is here. I'm going to go from power supply to the blower motor. From the blower motor, I'm going to go through 1 resistor after the blower motor and a second resistor for medium low speed. When I come out of pin 2, basically you can see I've cut one of the loads out in the series circuit given the layout of the diagram. As a result, my total resistance in the circuit goes down, and we can infer with basic mathematical reasoning that amperage goes up, fan speed is going to climb. Position 3 here is listed as medium speed, and we go there to medium speed. So we got low, medium high, and I don't know why they don't have it listed that way. They've got high speed and maximum speed based on where air is coming from. But I'll call this medium high. I switch to position 3. So now I go from the power supply using this diagram to the blower motor, from the blower motor through the blower motor resistor through only one resistive value in the resistor to ground. So now I have one load here that's engineered in the circuit. That's the perceivable load. We see it operating. We feel the air moving. And one load here to ground. What I've done is cut the resistive value of the series circuit again down even more. Amperage is going to go up. Fan speed is going to climb. Now I want to go to complete high speed, or what they're calling maximum speed. In this scenario, I want to operate just the motor itself and not use any of the other loads in the blower motor resistor to turn this blower motor on. So if I go to high speed, which they're calling again position 11 here, maximum speed, I go from my power supply to the engineered load straight to ground. How many resistors do we have in total? Just one. So I've cut the resistive value down again significantly. That's going to force this fan speed to climb and give us our maximum output. Now you will see in these diagrams there is linking to other components. This is a feed point to the heater control module as called out by Ford in their service information. It's on a 0.35 millimeter squared black and red wire. This feeds over to our next circuit to our heater control module. Now here is where things can get a little scary for us as technicians. First thing I want to throw out here, this module, notice there is a solid line around this module. That means you replace the whole component and not subcomponents. What I do have to call out though is that there is a dotted line between this number, 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 all these are listed through here. What that dotted line represents is that we have more terminals. These numbers, these small numbers are terminals. That's terminal 2, terminal 8, 6, 3, 10, 1, 16, 14, 4, 7, 12, 9. You can see that we're missing some of the terminals between 1 and 16 on this view. Those are all part of C380. And C380, if I go to a zoom print feature on this, let me scroll in or zoom in a little bit, and I'm going to use the hand here. C380 is the connector. So a connector is basically the plug that includes all of these terminals that go to this heater control module on this particular vehicle, but all those terminals are not shown in this particular image, this diagram and service information, because they're not always needed to go through your diagnostic procedure. All right, now down here I've also got another diagram, includes the output for my AC compressor clutch down here. Again, if it's an electrical component in the diagram, this AC compressor clutch connector 957 has 2 pins, 0.75 millimeters squared, green with a yellow wire is the power supply feed for the AC compressor clutch, and we've got a 0.75 millimeters squared black wire that's going to be the ground supply for the clutch. Now you'll see again there are some callouts in this particular diagram. So I'll go ahead and click on this. It says G56. Notice G56, G standing for ground, 56 standing for under the hood somewhere. G56 is also a common ground for multiple other components on the vehicle. If I've got a dual horn vehicle, G56 is going to be the ground for the dual horn. If I've got a single horn vehicle, G56 is going to be a ground for the single horn system. Also, all of these other loads and or components rely on G56 for a ground point. Fog lamps, headlamps, parking lights, AC compressor clutch, the clutch diode system that prevents voltage kickbacks, engine cooling fan motor for different options, and the secondary cooling fan motor, and then also the cooling fan motor diode. The reason that's nice to know and really need to know when we're dealing with service information is if we have a car that comes in and the customer's complaint is my horn doesn't work, my right fog lamp doesn't work, my cooling fan motor doesn't work, and maybe my AC compressor doesn't work, those are noticeable symptoms that the customer throws at you. Having access to a wiring diagram may show you that G56 is a common point where there could be a failure that shows up in a diagram. So again, that's how it's going to help us specifically in appropriate context. Now I'm going to go back. Again, I'm electrical, so I typically deal with that side. I'm going to go into the OE, or I'm sorry, the non-OE options here, and we're going to go through the blower motor again using the aftermarket rendition of service information. I'll show you the convenience of it. So I'll click on the non-OE. Let's see if I can find the blower motor in this list, and that is going to be part of the heating and air conditioning system. This is a manual AC circuit. Give me a moment here. I got to plug in my charger. See if I can make a bunch of noise in the background. But notice this diagram does look a little different from the factory diagram. Give me a moment. Get this plugged in. Okay, we're ready to roll again. Charging back up. This diagram shows us all of the same components we had in the earlier version, the original equipment manufacturer version, but notice the layout, the way it's presented is different. And I'm going to go to the zoom print and show you what's been embedded into this design that helps us as a technician when we're going through the diagnostic process. So earlier, let's see if we can find the blower motor laid out in this particular circuit. There it is, heater blower motor, and it even gives a description with the aftermarket side behind the right-hand side of the dash. So that 30 amp fuse we were looking at earlier is feeding power directly into the solid state. It's a brushed DC motor, and this is going to be our ground point. Now notice when we get down here, we have a similar arrangement, or really the same arrangement, just with a little bit different mapping on the screen. I've got a fuse integrated into the blower motor resistor. Tells us where our connectors are at, or our splices. It says splice 24 behind the center dash panel. I've got my heater blower series resistor laid out. If I click on this box, you can see that box is connected to multiple other circuits. So this feeds now our heater blower switch. This heater blower switch, I know this makes it look kind of confusing. This is one continuous path. Here's our power supply, here's our engineered load. If I was in low speed, I would divert through this path right here, go to ground. I'll get rid of these views for a moment, that way it's a little bit more clear imagery. So I go to low speed. This is going to be my low speed path. This is going to act as my ground point. Current's going to flow through here, hit all three of these resistors, go through the ground here, and we can see where this is tied in. If this switch was the low speed point right there, I would connect then to this portion of the circuit, this portion of the circuit. I'm going to hit all these links, and that would take us to ground. Now if I get rid of that, I can go to the medium speed. Medium speed is going to be here. Now notice the manufacturer or the aftermarket redrew this diagram as an interactive map. So if this is my medium speed, I've bypassed a resistor. This is going to be my path of current flow in this layout. So we can see the benefit of using this type of service information that the aftermarket has redrawn. One, it's really inclusive, includes a lot of things in a diagram, but the most prioritized thing for me as a technician and a technician educator is that we have the inclusion of interactive features. Sometimes when we're looking at a factory diagram, we can go, what color was that wire again? Well, I know if I highlight this wire and it says it's black and red, I can follow this black and red all the way down to at least a splice point. Okay, what color is the wire going into the blower motor resistor for a low speed setting? That's going to be black and blue. What color is the wire going out of the blower motor resistor for all low, medium, high speeds? That's going to be the black and white feed for low speed, medium low is here, medium high is going to be here. So we get all those color variations that give us indication in an interactive method that helps us pinpoint where we're going to go through a factory diagram. So now that we've gone through that, something else I want to throw up here in this particular system. One is going to be specifications. Now these are typically critical for us as technicians. Why? What are specifications? Specifications are values that manufacturers set that say this is my current flow capacity, this is the resistive value this component should have, this is the amount of inches or millimeters in diameter this piston should be, this should be the ring in gap on the engine assembly. We use those specifications really as go, no-go for making a repair or replacing or servicing a component. So I'm going to click on electrical again. Notice we got kind of a broad list of things under the electrical side. So I'll go to fuel injector. Look what the manufacturer gives us. I suspect I have a fuel injector problem. I disconnect the harness. I go to the individual fuel injector and I want to check the resistive value. Ford says that the fuel injector should have a resistance of 11.4 to 12.6 ohms. So this is going to be the specification. We rely on its technicians as a final component test to determine if the fuel injector meets the manufacturer's specifications. If it's outside of this window, using the information the OEs give us, we can replace the component. And something you want to consider, these are not always going to be 100% accurate. These are numbers that are derived by the aftermarket companies subscribing or having access to the OE side and rendering it in an aftermarket format like ALLDATA. Having said that, if the OE says this is an acceptable range, the aftermarket is going to use the same approach for finding what the acceptable range of resistance is going to be within a circuit. Now, something else that's kind of cool about the way that ALLDATA has laid this out, if you notice over on the right-hand side, what exactly is a fuel injector? Can I get a description of what this thing does? I click on the link. I get an exploded view of the components that are, or the subcomponents of the injector, the variations I might find physically between different manufacturers of the fuel injector, how the component is laid out, and essentially I get a description of how it operates. Fuel injector is a solenoid operated valve that meters fuel flow to the engine. Injector is open and closed a constant number of times per crankshaft revolution. The amount of fuel is controlled by the length of time the fuel injector is held open. So service information gives us that benefit. I'm going to go back. We're going to have a similar list here. I'm going to have a connector view. What do the connectors on the injector 1 look like? Should be one connector with 2 pins. One's going to be a constant voltage feed in, and one is going to be a switched ground. So that is going to be critical for us depending on the type of injector that we have. Notice there's 2 connectors that are thrown up here. And if I go back again, and I go back into this description, notice I have a Siemens brand or a Bosch brand. Siemens is SMM, Bosch is going to be the EV6. So let's go back to this view. One might be a Siemens, one might be a Bosch, it might be vice versa, but we'll know based on the physical features the injector has. That way when we call the parts store, because we verified the resistive value of this injector is bad, we can then say I have a Siemens injector or I have a Bosch injector for this year, make, model, submodel of vehicle. Now most of you guys are probably in the engines class or a more mechanical systems class like steering and suspension. So I'm going to go into engines, for example, and show you how much detail ALLDATA provides us with as an end user, and then we'll look at pro demand as we progress. So down here, I clicked on engine as a subcategory of engine cooling and exhaust within the vehicle, and I get this massive list of things. Let's say a customer comes in and I do a quick inspection and find out that they need a timing belt. So down here, I've got 4 columns under the emboldened timing belt. I hover over it and highlights. If I look over here, notice I've got repair procedures. If there's repair procedures for the aftermarket available, they'll give them to you. If there are parts in labor times and part numbers, the aftermarket will give it to you. If there are any TSBs, and TSBs are technical service bulletins, we'll look at those in a moment, and then also specifications. So I'm going to go back to timing belt, and notice we've got repair procedure. We don't have measurements for the timing belt. We don't have bulletins for the timing belt, but we do have parts and labor. So in the repair process, I'm going to go to the removal and replacement link once I've selected timing belt info. First thing they give you, what tools you're going to need to perform this job. I can't tell you how beneficial that is as a technician. Does the tool have this, or does the employer have these tools available for me to use? And that's going to be critical for us as technicians in completing a task. So we've got a camshaft alignment plate. You guys will use this for your engine class. A timing peg for pinning the crankshaft in place. Remover and installer for a hose clamp assembly when you start disconnecting some of the cooling system hoses. Cam pulley remover, spark plug wire remover. These are all what the original equipment manufacturer prescribes you should have or must have for performing this job. Now you can work your way around some of these tools like the hose clamp remover installer. You might be able to use a set of pliers. The spark plug wire, you might be able to use a set of pliers or pull them off by hand. Just this is what the OEs recommend. Now down in this list, we go step by step. How do you set the engine position? How to raise and support the vehicle? What to disconnect first? What components are on the vehicle in the teardown process? The great thing about this is basically our instructions. We verified the timing belt is bad. Now how do I replace it? So notice we're walking down the line here. They're even going to give us the torque value of the fasteners that are on the front timing cover on this vehicle, the disconnect procedure, how to offset the tensioner assembly on the vehicle to detension the timing belt, how to go through removing the cam gears if we actually need to do that, how to increase slack or decrease slack, how to install these special tools that the OE has said we must have to tear this component down. And the process is pretty nice and laid out. We also give kind of step-by-step imagery showing the arrangement of components on the vehicle. So notice we've got our cam gears up top, we've got our crank gear up top, we've got a tensioner right here, and we've got basically an idler pulley right here on this side. So this is what it should look like in the teardown process. Now we go to the installation procedure, and notice that the steps start all over numerically down here. We follow this down, we align our index marks, we use the appropriate process and the specifications of the installation, put the vehicle back together step by step by step, and hopefully get it back on the road. Now one of the questions we might have about this, and I know I scrolled through it pretty fast, how much time am I going to bill for this? Now notice in each of these service procedures, removal and replacement of this timing belt, not only do we get the tools required, the procedure, the step-by-step analysis of tear down, remove belt, reinstall belt, torque fasteners, sequence, specifications. Over here we get parts and labor. So this is a factory Ford part number. This is what the list price is. This is not going to be cost, and I don't know how frequently the aftermarket updates this information, but this cost is going to be typically the list price, what the consumer pays for the part, not necessarily what the shop pays for the part. Down here, if I'm removing the timing belt, warranty will pay 2.1 hours. It doesn't take a lot of skill to tear it down, the way that the skills are tiered between A, B, and C, so this is a mid-range skill level. Warranty pays 2.1 hours, but if you're in the aftermarket, notice we're using ALLDATA. This is aftermarket service information. Standard time is going to be 3.1 hours. And that's going to be at your discretion. Do I charge standard time? Do I charge warranty time? This is what an OE would be billed. This is what the aftermarket will typically bill. If I've got to pull that crankshaft gear off, the drive gear for the entire timing belt, I'm going to add 0.2 of an hour. If I've got to pull and replace the idler pulley, I'm going to add 1/10 of an hour. If I've got to pull and replace the tensioner, I'm going to add 1/10 of an hour. So I've got 4/10 down here plus 3.1. I've got 3.5 hours of billable time for removing and replacing the timing belt on this vehicle and following the procedure that's given to us. So again, we can see the value of service information and its importance. So now I want to show you this Tsb list. Now TSBs are going to be found in popular information, or if you go into subsystems, areas of particular service, those TSBs will show up and give us an indication as to what problems may be present on this particular vehicle in a subsystem. So I'm going to click TSBs here, which should give us kind of a mastery list. Notice, highlighted here, it says all TSBs. So all of the technical service bulletins. Bulletins are essentially, I got to throw this out there, it does say recall here. Bulletins are essentially problems the vehicle may experience over its range of manufacturer that could be somewhat common that aren't necessarily safety or emissions related. NVH, which is noise, vibration, and harshness, is a very, very big growing area for vehicle manufacturers they have to address because they experience so many customer complaints that the manufacturer has to respond by creating new diagnostic routines or updating diagnostic routines or new procedures or new components or subcomponents to fix the complaint the customer might have. So notice this one here, TSB number is 11-3-24. It was released on March 31st of 2011. And again, this is a 2001 Ford Focus wagon. So this was 10 years later. Engine vibration at idle. I'll click on this. And here we get a summary. So the Ford Focus from 2000 to 2011 may have the issue of exhibiting an excessive engine vibration at idle, most noticeable when the transmission is engaged in reverse. The condition may be caused by small stones, road debris, ice or snow packed or lodged in the rear engine roll restrictor. So basically this is a mount, a rear engine mount that's stopping the engine from rolling and changing some of the torque that's noticeable out of this really high performance 2-liter inline or longitudinal 4-cylinder engine. So now in the service procedure, they'll have you scroll down, follow the process, find out if there's any debris, clear it out, put a service shield on, and notice that service shield comes with a OE part number from the manufacturer. They'll give you the range of years that it applies to and the torque specifications for the installation. And down here is basically the billing. How do we bill this out as an OE site of repair? It would be operation description time. We would have 3/10 of an hour for the inspection, cleaning, and the installation of the shield. And if I was working again for a dealership at a Ford dealer, I'd bill out 3/10 of an hour to install this service shield, and I'd submit my time. Now I want to show you this. I'm going to see if I can find a pretty bold recall here. Here's one, and now I want to compare real quick. That engine vibration is not going to cause you to be concerned for your safety, and really doesn't create any real safety concerns. If I scroll down here, notice there's one that says recall, and I'll see a few of these that are called out as recalls underneath this vehicle. Recalls are safety and or emissions related. So this vehicle was manufactured this way, and these are the complaints we're experiencing. Now these recalls will be sent to the current owner of the vehicle. They're typically proposed to the National Highway Traffic Safety Administration. The manufacturer will do their investigation and determine whether or not we have any safety or emissions concerns on the vehicle that are non-compliant with NHTSA standards, FMVSS standards, the Federal Motor Vehicle Safety standards, or the EPA standards. So to all dealers, safety recall 05S27 supplement number 2. So this is the second attempt to fix the issue. Some 2000 to 2005 model year Ford Focus 4-door wagon, and 5-door vehicles originally sold in or currently registered in corrosion states may experience this rear door latch corrosion. So these are the states that are included. Now what I have to say is oftentimes the included states or the included areas across the nation will grow if there are revisions. Now, I want to go back because this one was released, again, November 7th, 2005. This was the initial document. However, if we note, I go down here to the recall. This was released November 7th, 2005. I scroll down. I've got another recall that was released January of 2005, and it has a NHTSA number attached to it. So this was an older rendition for a rear door latch corrosion. We get a list of states that may experience these problems. Built for corrosion in the pawl pivot area, the rear door latch can cause a binding condition of the pawl that may affect proper engagement of the pawl and the latch. Basically what's going to happen is the door is not going to close easily or the way it should, and if it doesn't latch properly, the door may open while the vehicle's in motion. If an occupant fell out of the vehicle, personal injuries could occur. So initial complaint here, Ford addressed it, and then they updated the process with the recall we look at right here. So now we scroll down, we get the description. At no charge to the vehicle owner, dealers are to inspect, clean, and lubricate the rear door latches, install a lower rear door seal, and information labeled the rear doors on all the affected vehicles. That's showing that The cleaning process and the installation of the new seal has been done, and it documents that this repair has been made. Now, a note that was included here in this release: some 2005 model year vehicles were built with the door seal. Don't remove the existing door seal, but do complete the rest of the service procedure. So you can see in production sometimes they've done some updates, but just want you to clean rather than replace the seal and clean. They're having you just clean and lubricate the components. So this is a recall listed within the TSB column. I wish service information would separate the two. Maybe we'll see that in the future, but these are campaigns that could be open. Now, the nice thing about the recalls, I'm going to change vehicles here, and I'm going to go to like a 2010 Chevrolet Cobalt with a 2.2 4-cylinder naturally aspirated. If I go into powertrain management and I go into all TSBs for this vehicle, I get a massive list again of technical service bulletins and or recalls that are included in this system. Now, some of the fuel systems on the Chevy Cobalt that were California built had consistent fuel leakage issues you'd find on the gas tank. If I was a customer and my vehicle was outside of the warranty period, the recall would still apply. However, if I left California when the recall was established and I moved to Illinois, since I wasn't in the covered territory, manufacturers may have the ability to say, this problem doesn't apply because you're not in that state, you're not in that territory, you're not in that region. We're going to deny it. Fortunately for us as technicians, if we push the issue with the OE, when we isolate this problem, a California car that landed in Southern Illinois, and we find out that it's got a fuel leak, for example, using this Cobalt, we get a hold of the OEs, oftentimes we'll find that they update the campaigns or the TSBs or the recalls to expand to broader reaching regions across the nation. That does two things. One, it allows the customer to see that we're advocating for their needs. If you're in portions of Madison County, you can't get through the test lane with an evaporative emission system leak that would be generated based on the manufacturing defect of that fuel system seal leaking. Two, if we can reduce the cost for the customer and pass that off to the manufacturer whenever we're performing these procedures, chances are I think you're going to be successful in recruiting more customers because you've reduced their cost while guaranteeing that the repair was done correctly on that particular vehicle. So I'll leave this one alone, and now we're going to go over to Mitchell on Demand. It's called ProDemand. So if you type in prodemand.com and you're on the college's network, you're going to click Login. Within this side, you're going to see that, again, we've got a similar process: year, make, model, engine, submodel, and other options. So I'm going to pick I got a 2015 GMC Sierra with a 5.3. It is an SLT option. It is just a gas vehicle. It is a crew cab. It is 4-wheel drive. It does have a 6L80, so all this is plugged in. I'm going to click Use this vehicle. Now this layout looks different. I'm going to pick the same vehicle over here, 2015. Now notice I have to pick between GMC truck. It is a Sierra 1500 4-wheel drive. It does have the 5.3. Notice the difference in layout from one side to another, and this is oftentimes an argument in the aftermarket. Who do I like the best? Do I like ALLDATA or do I like ProDemand? Personally, I don't care what your preferences are. I grew up in times of ALLDATA where we had to insert discs into the computer for year, make, model, submodel. But ProDemand in their IP or their virtual option has done a fantastic job. The nice thing about the way this is laid out up front, let's say I've got a complaint. I go straight to this screen. I'm going, oh my God, there are so many options for me to pick. I want to find out if I have a condenser leak in an AC system. I'm going to search condenser. So if I go to condenser on the vehicle, boom, now I get this big approach where I have Real fixes, failure counts, common issues that customers may or technicians may have had with addressing AC condenser problems, top repairs, causes and fixes, specifications for removal, installation, and testing, OEM testing procedures, wiring diagrams, parts and labor, and again, procedures for removal and replacement. So let me go to causes and fixes. Air conditioning inoperative. Notice the relationship they have with the condenser being problematic. Fluid leaks from the vehicle. Notice relationship they have with it being problematic. Fluid leaks from rear, air conditioning condenser. I'm going to click on this AC inoperative because this is what I experienced. We get a list down here of components that were typically replaced. 4,570 accounts of the air conditioning condenser being problematic with the AC inoperative complaint. Some of them had refrigerant that was low, some of them just had O-ring seals leaking, radiator, I'm not really sure what that has to do with the condenser because they're two different components, AC compressor, service port valve leaking, expansion valve leaking. So if I got this car that comes in, or this truck, 2015 GMC Sierra, shows up to my shop and I go, man, the customer complaint is they don't have air conditioning. If I go into the AC system, I shot dye in the system, I find a leak at the condenser, I can find out that quite a few of these condensers have been replaced successfully to address the concerns that were present. And this really shows you the relationship. Only 18 of the complaints were the installation of an AC compressor kit. However, 4,570 AC condensers have been replaced since this truck was born in the aftermarket to make a successful repair. So this shows you kind of the likelihood of faults, and I don't want to tell you that's a good thing at all times, because you may lead to a conclusion based on digging through the top repairs, the causes and fixes, the real fixes, replace a part without doing any testing, and what that turns into is maybe that part wasn't bad. Maybe you had something else wrong. Maybe you had a line that was leaking and it wasn't the condenser that was leaking. Let's go back to home. So something else we got listed in here, the way that, again, the aftermarket works here, notice we've got this keyword common amongst all of these areas. Commonly replaced components. Well, it looks like brake pads are pretty common for users of Pro Demand that are working on a 2015 GMC Sierra. Common DTCs. Random misfire is very common on this truck, apparently. Common symptoms. Now, it's kind of funny. I said the air conditioning inoperative earlier with the condenser. The most common symptom experienced by reporting users who are diagnosing the air conditioning inoperative on a 2015 GMC Sierra. We've got 11,935 of those symptoms reported in service. Over here, we've just got a massive list. Additional results are going to show up as well, but I'm going to click on this inoperative AC or air conditioning refrigerant. I click on this again. Boom. Look at this. Top repairs. I see this matrix that kind of lays out the real fixes that were verified, the range of mileage, and what those real fixes were on this particular vehicle. So another clue for top repair, gives you a little bit of leverage. I feel comfortable with my diagnosis. I'm going to go through this process. Now, since I live in the electrical world, I'm going to go ahead and click on diagrams, and I'm going to go to let's say the system wiring diagrams for this vehicle. I'm going to go into, on this particular vehicle, let's use the let's go to the computer data lines. I want to talk to the communication network on this vehicle. Maybe I am trying to speak with a right rear window switch on the LIN bus, the Linear Interconnect Network bus number 4. For whatever reason, my right rear window switch is not reporting data across the network, and I'm at the body control module, which should be receiving this information. I'm on the GM LAN, which is a local area network part of the CAN bus system, and I've got a higher speed on the LIN bus that's going to show up. I may want to go to Terminal 1 on the Linear Interconnect Network bus of the right rear window switch and find out if my LIN bus data is being sent from the right rear window switch when I make a request to roll the window up or down to the network. So that's going to help us out pretty frequently. Where do I need to go to pinpoint? Headlights. Another situation here. I get a massive layout. I've got power here. Chances are I'm going to have ground somewhere down here in the diagram. I get the location. I get a description of the location on this particular layout. And my headlamps aren't working. My high beam headlamps aren't working. Notice this diagram shows me the headlamp high beam relay. I've got one fuse that feeds both the left hand and the right hand headlamp. That feeds directly to my illumination lamps down here. This diagram within service information is going to give me leverage to walk through the process. Hey, what is this X10 connector on this vehicle? What is this white wire on this terminal C going to indicate to me that's light blue when I go to this left high beam headlamp point? Should I have voltage here, yes or no? If I use the diagram in its layout, when I turn this relay on, I should see voltage down here. So a little bit of a difference between the two types of service information we get that are commonly found in the aftermarket, but both of them are going to be beneficial for us. If you got any questions, please bring them up in class. Other than that, I'll remain silent and I'll post